Let's determine whether the series sum from n equals 1 to infinity of 1 over n factorial converges or diverges. To analyze the series, let's first write out the first few terms to get a better understanding of how it behaves. The first term is 1 over 1 factorial, which is just 1. The second term is 1 over 2 factorial, which is 1 half. The third term is 1 over 3 factorial, which is 1 sixth. And the fourth term is 1 over 4 factorial, which is 1 over 24. Let's create a visual representation of these terms on a number line to see how they add up. Here's our number line from 0 to 2. The first term is 1, so we'll mark that point. The second term adds 1 half, bringing our sum to 1.5. The third term adds 1 sixth, bringing us to about 1.67. And the fourth term adds 1/24, bringing us to about 1.7. Let's observe what's happening. Each term is getting much smaller than the previous one because we're dividing by larger and larger factorials. In fact, the denominators are growing extremely quickly. 1, 2, 6, 24, 120, 720, and so on. This series is actually related to a very famous mathematical constant. The sum of the series plus 1 over 0 factorial equals E, Euler's number, which is approximately 2.718281828, since we know that E is a finite number. And we're just subtracting 1 from it. We can conclude that our series converges to E minus 1, which is approximately 1.718281828. This convergence makes sense intuitively because the factorial in the denominator grows so quickly that each term becomes extremely small very rapidly, ensuring that the sum approaches a finite limit.